All right, welcome back again. This is the methods of mixture separations. If we have a mixture, like you should have already learned about compounds, elements, and mixtures. When we have a compound, it can only be separated by chemical means. If you have an element, it cannot be separated except by nuclear means. But when you have a mixture, you can actually physically separate that by mechanical separation. So this is the video on, so label this one methods of mixture separation. Okay, so first off, again, copy everything in your notes that I highlight, underline, or star, or write myself. So if you want to write anything else down, go ahead and do that. Okay, so basically one of the things that we do is mechanical separation. Okay? Mechanical separation is simply, I'm trying to highlight that. It's just basically picking it out. So like if I take these, I think these are M&Ms, or I'm not really sure what these are in this bowl, but I could take the reds, the browns, and the blacks and separate them. We do that with recycling plastic, papers, and metals. Okay, so we basically just pick them out with tweezers or something. Okay, so that's one method of separation. We could also do a magnetic separation. Okay, so if we have sulfur and iron together in a mixture, I can take a magnet and I can get all of the iron out of the sulfur, or as much as possible, and just have the sulfur in one pile and the iron in another. So some other examples are like at a scrapyard. That's how they do some of that metal, to get through the metal. I'm not going to show this video because I tried it. I didn't really like it, so I'm not going to use that one. But this is another method. This is a really good, and we use this quite a bit. It's filtration. Filtration takes advantage of the physical properties of the state of matter. Okay, so we are separating solids from liquids. Okay, we use a screen that lets the liquid particles through but traps the solid particles. So when you make coffee, so you don't have grounds in your coffee, you have a physical, a filtration separation. All the grounds stay in the filter, and the liquid gets all the other particles come out. Spaghetti, when you make spaghetti, you dump out all the water, and all you're left with, and the starch comes out also, and all you're left with is the spaghetti noodles. We also use this windows. You don't want the bugs coming in your house. You put a screen in front of it. The bugs can't get through. The air can. Okay. We have another one is decanting. It's to pour off a liquid, leaving another liquid or solid behind. If you have grease and water, like when you're trying to make gravy, you have this decanting. You can decant it, and all the good liquid, like when you bake a turkey, you can get all the grease on top, and you have all the good juices on the bottom to make a gravy with if you're making your own gravy. That's decanting, to pour off. My daughter makes something called horchata, and she does this with horchata as well. It's like with rice, and they um, get the liquid from the rice. So if you're familiar with that, like horchata, that's decanting. Okay. Distillation. The way we get distilled water is through distillation. It is the separation of a mixture, separation of a mixture of liquid based on the physical properties of boiling point. So we're going to basically boil the substance and capture parts of it at different places. Okay, so distillation of alcohol or oil. When I was in college, we did this one, and we had these tubes filled with beads, and all of um, the water vapor would get collected in those beads, and we'd drain off the water, but then we had like ethyl alcohol that was kind of like an oily substance, and we collected it at the bottom. If we had water on it, it would sink to the bottom and the oil would be on top, and then we knew we didn't do a very good job. But if we had pure substances on the other end, we knew we did a good job of it. Okay. Excuse me. Distillation tower are still used in crude oil refinery. That's kind of how we're using it in the real world. Okay, that's why you see all those towers. All right, this is the one you're probably most familiar with, but don't know it. because most people don't realize this is a method of separation, is evaporation. Vaporizing the liquid and leaving the dissolved solids, and there's the key, behind. So if you have salt, if you've ever made in your kitchen, you had water in a pot and it started to boil and you get that white crud in your pot, well, that's because there's some stuff in our water, like the hard water substances, that when you boil the water off, it ruins your pan a little bit because you get all that hard solid out there. Now, if you had salt water, you could do the same thing here. So you could take sea salt and evaporate the water out of it, and you get the pure salt from the sea. Okay. All right. Density separation. Density separation is more dense compounds sink to the bottom and less dense compounds float. The compounds cannot be soluble within each other. So like your oil and your water, they have a density separation because your oil floats and your water sinks. This is one you're probably not familiar with, but if you ever have blood drawn, they do this one. It's called a centrifuge. It's a circular motion, and it just basically spins the substance around extremely fast, and the denser components sink to the bottom faster. And so when we want to do separation of blood, this is how they test your blood for like diabetes. What else do they test for? Thyroid issues. I just had blood work done this past summer, and they took like 3 or 4 vials of blood for different reasons. And when I get to the doctor, they know what my cholesterol is and all that other good stuff. Okay. All right. This is one we're probably going to try to do in class as a lab. Paper chromatography uses the property of molecular attraction to separate a mixture. Different molecules have varying molecular attractions for the paper. So one of the ways we use this, it sounds really funny, but they're used in pregnancy tests and drug tests. So if you ever have any of these, this is like when you pee on a stick for pregnancy or even on a drug test, there's different hormones and different particles that go through and they stop at different levels on, there's my pen. I can't find my pen. Well, if I touch the thing, the hormones start traveling and the particles start traveling. Now they're going to stop at different places along this filtration. So if you are pregnant, that pregnancy hormone is going to come all the way to the top, and you're going to get that plus sign. Okay. If you have a drug test, each one of these little places is a different drug, so they could kind of tell what drugs you're on if you're having a drug test. We're not going to use it for either one of those two items, but we're going to use it in a different way. All right. Okay, so there's another one. We have fractional crystallization. This is how we make rock candy. We're going to talk about solubility limits later on, and we're going to talk about saturated, supersaturated, and unsaturated. So we're going to talk about all that good stuff there. We're not going to finish too much on that. So that's the end of our separations. So go ahead and take notes on this and bring it to class. See you in class.